Hello, my wonderful students. Welcome back to your science class. So, students, today we will continue our chapter Physical and Chemical Changes. So, students, we will study about types of changes, rusting and its prevention, crystallization. So, let's start. So, let's study about physical and chemical changes. Physical change. A substance is usually identified by its physical properties, shape, size, color, state, etc. Students, we know that water is wet and gold is shiny. That is how we identify them, right? When there is a change in any of the physical properties of a substance, its shape, size, color or state changes, right? So students, this type of change is known as physical change. No new substance is formed in this type of changes. It is usually reversible, right? It is usually a reversible change which can be reversed. Let us take a piece of paper and crumple it. What happens to the paper? Yes, the original shape of the paper changes because you have changed the body of the substance without changing the composition. You have only changed the appearance but not the composition of the paper. So, students, you have not made a chemical change but a physical change. Take chalk and crush a small piece of chalk into dust. Yes, and add a little water to the dust to make a paste. Roll it into the shape of a piece of chalk. Let it dry, students. Did you recover chalk from the dust? Yes, you will obtain the chalk. So, students, this kind of change is known as physical change. Now, take some ice in a glass or plastic tumbler. Melt a piece of small portion of ice by placing the tumbler in the sun. You have now made a mixture of ice and water. Now place the tumbler in a freezing mixture, ice plus common salt. So students, does the water become solid ice once again? Yes, water changes to ice on cooling in freezer. So students, take some ice cubes out of the freezer and put them in a beaker. Leave the beaker for some time. What would you observe, students? The ice would turn into water. That is, the state of matter would change. You want to inhale steam as you have a cold, you would still have the remaining half measure of water. Pour the remaining water into a suitable vessel and put it on the lightened gas stove. The water would start turning into steam, that is, the state of matter would change again. Thus, students, you would thrice have changed the state of water only to find that it was a physical change and hence reversible. I hope now it is clear what is physical change. Now we come on chemical change. A chemical change is a process in which substances are changed. Chemical change occurs whenever compounds are either formed or decomposed. During a chemical change, students, a chemical reaction takes place. A chemical change is permanent and it is therefore irreversible. That is, it cannot be reversed. Example, burning a log of wood, it turns into ash and the resultant ash cannot be changed back into log of wood. Yeah? Take a piece of magnesium ribbon and burn it over a flame. The magnesium burns with a brilliant white light. You will notice a white powder ash left behind when the magnesium ribbon is completely burnt. Students now collect the white ash and drop it into a beaker containing 30 ml of water, as you can see from the picture. Stir the water thoroughly and test it without litmus paper. It turns red litmus into blue, while blue litmus does not change the color. You can conclude that magnesium on burning in air forms a new product, that is, this. The change proceeds with the evaluation of heat and light. The change is permanent and irreversible. The magnesium is added to another chemical reaction with water, forming magnesium hydroxide MgOH2, which is basic in character. A beaker is half filled with water. A teaspoonful of copper sulfate is added to it. A few drops of sulfuric acids are now added to the solution. So students, do you notice that a blue color solution is formed? The solution is divided into two parts and kept into two beakers. An iron nail is dropped into one of the beaker. Wait for half an hour or so. What do you observe? Now compare the color of the solution kept aside in the beaker with the color now formed. So the now formed solution, or the now formed color in the solution with the iron nail, we will see. So do you notice any changes in the nail, student, after it is taken out of the beaker? There is a brown colored deposit of color on the nail, while the color of the solution has changed into green. This is an example of chemical change. Let us observe another reaction to see a chemical change taking place. Take 1 tablespoonful of baking soda and is added to 100 ml of water taken in a beaker. It is stirred well till all the baking soda is dissolved. 5 ml of vinegar is then taken in a test tube. With the help of a dropper, a drop of vinegar is put on strips of red and blue litmus papers. Bubbles are seen to have formed due to the evaluation of carbon dioxide. The mixture is stirred till only bubbles are left. Again, test the solution with red and blue litmus paper strips. Students, since vinegar is acidic, it turns blue litmus red. So students, when baking soda is added to it, the new solution does not bring about any changes in the color of litmus paper. Why? Because it has become neutral in nature. The vinegar acid neutralizes the baking soda base. Hence, this type of reaction is known as a neutralization reaction. Let us study the difference between physical and chemical change. Rusting is actually corrosion. Corrosion is this reaction between a material and its environment which causes the material to deteriorate and alters its physical properties. Take water in a beaker and add a few drops of dilute sulfuric acid to it before putting it to boil. When the solution starts boiling, add powdered copper sulfate and keep stirring it. Make a saturated solution, keep on adding copper sulfate till no more of it can be dissolved. Filter the solution and let it cool. Leave it undisturbed while it cools. What do you observe now? Crystals of copper sulfates are clearly visible, yes? So this was an example of chemical change. That's all for today, students. Thank you so much. I hope you all understood the chapter, that is physical and chemical changes. Thank you, my dear students.